Hello class, this is a walkthrough for two calculations that you're going to be doing today. It's a little bit different. We're going to be working with molarity, but you're going, instead of coming up with what we were doing the other day, we're going to actually, the first type of question is going to say, what is the molarity of carbon dioxide in a 555 liter solution would be created if 3,383.258 grams of methane were used during this chemical reaction? You're going to say, well, how am I supposed to solve this problem? First of all, I balanced the problem for you. You should already know how to balance these chemical equations. Those are very important when you start coming up to trying to do these. Okay, you're going to go back to that same thing we've done before. When you're talking about it, you see I have it worked here. I'm going to make it easy for myself. Copy, paste. Remember we was talking about the stoichiometry about a week or so ago. We talked about from the grams of the known and then to the moles of the known, and then the moles of the unknown and grams of the unknown. So that's kind of what we'll be dealing with this today. So first of all, you kind of look at that and you say, well, you were given the grams of the known, because something we know about is we have 3,383.258 grams of methane. So let's go ahead and cut and paste that, copy and paste that rather. Paste, let's make that, there you go. So we have 3,383.258 grams of the known, and this is methane. Now you got to come up with how you come up with the moles of the known. You got to remember you take that total amount of grams, given grams, divided by the molar mass. So you have to come up with the molar mass of methane. Methane, remember how to do that, I hope. CH4, you should know methane CH4. They're talking about this right here, CH4. Molar mass, then I'm going to cut and paste again. Well, excuse me, copy and paste. Copy and paste. You need the molar mass of that in order to calculate the number of grams, okay? So once you have a number of the molar mass, you've got the, divide that by there, you've got the molar mass there. You take the molar mass of CH4, carbon is 12.01, and you add to that 4 hydrogens, right? So that comes up to a total of 16.042 grams per mole. Hopefully you remember how to do that. Then you have to take, the way you come up with the number of moles, you take your given 3,383.258. Well, let me just do, I've already got it done, so let me just cut and paste on that again. Sorry about that. Or copy and paste. Copy, paste. So now you have the number of moles of your known. So you have 210.90, 210.900 moles of your known. So you're already partly the way there. So you've got your grams were given. You divide what is given divided by the molar mass of methane, which is 16.042. So 3,383.258 is given divided by the molar mass, 16.042. That gives you 200.900 moles of the known. And if you don't remember how to do the other one, you come up with the number of moles of your unknown. You take your moles of your known and multiply it by the coefficient of your unknown divided by the coefficient of your known. So the unknown, we're trying to find out carbon dioxide here. So it will be 210.9 times 1 divided by the coefficient of methane is also 1. So this makes it easy. So therefore it's going to be just 210.900 times 1 over 1. Doesn't really change anything. This gives you the moles of your unknown. So the moles of your unknown, we'll just make these big like I did on the other one, makes it kind of stand out a little. There you go. So we also have 210.900, 210.900 moles of your unknown. Hopefully everybody understood how to do that. You took your moles of your known, 210.900 times the coefficient of your unknown, 1, divided by the coefficient of your known, which is 1. That leaves it the same as 210.900. Then you say, well, what about the grams of that? You're not worried about the grams for this one because the calculation has to deal with, if you don't remember, the formula for molarity has nothing to do with the moles of the unknown. The grams of the unknown. You're having to find out the moles of the unknown. You already have that. So all you have to do is you're trying to find the molarity, so you're looking for capital M equals the number of moles you have of your unknown is 210.900. Then all you have to do is divide it by the liters of solution, 555. And this will give you molarity, copy. Molarity, therefore, comes up to 0.38 molars. There you go. So there you've got the first one done. So number one's done. So you need to do 2, 3, 4, and 5 like this. While I'm thinking about it, tomorrow we're going to have a test on this. We're going to have a test on this, and it's going to be graded, but it's not going to count against you. But please do it because this will know. You'll find out how much you really know about this stuff. If you don't do it, then you're not going to know. And I'm going to grade it. I'm going to let you see your score. This will be the test that you would have had if you was in class, or approximately that. Okay, so just kind of let you know, this would be what you would have seen in class. Okay, for the next one. Next one you have the number 6. This is a little bit different because this time you're looking for the volume. You already have the molarity given, but you're looking for the volume, but it's the same process almost exactly. You take the 4-step process we've done before. Grams to moles, moles to moles, moles to grams. Then you take your number of moles, grams of your known. So you have 38,112.95 grams of your unknown. Then once again you take your grams of your known. Once again you take your given divided by the molar mass, and this time you got the molar mass. You're talking about the molar mass of iron, which is so you take the molar mass of iron 3 oxide rather, because that's what you have, iron 3 oxide. So therefore you take the next step. Then we take your given divided by the molar mass. That gives you 367 moles of your known. 367. Once again, let's make these bigger to give them more drama stuff. Okay, so we've got the number of moles of your known. Now you go back to the same issue you did before. You take that same thing we did in the stoichiometry regular class that we did, the regular problems. You take your moles of your unknown, times your coefficient of your unknown divided by the coefficient of your known to come up with the moles of your unknown. 367 is the moles of your known. Times that by 367 moles of your known. Multiply the coefficient of your unknown. We're looking for iron here. Iron. So iron is 1. Oh, it's another 1 by 1. So never mind. It's still 1 over 1 over 1. You see that because you're looking for iron. You're looking for what is the volume of solution required to obtain this for iron. This is your given because it's giving you the amount of grams of iron 3 oxide. So it's 1 over 1. So it comes up to, once again, 367. So the moles of your unknown is, once again, is 367. Do I need the grams? No, you don't need the grams. Not needed. Because once again, you are dealing with that formula. Molarity equals the number of moles divided by the volume. This time you're looking for the volume. You're not looking for the molarity. So the molarity equals the number of moles divided by the volume of solution. Remember this? We went over this formula a couple of times last week. This is also on your formula chart from the state of North Carolina, the chemistry reference table, on those formulas that start off with density and go down. I don't know, it's about halfway down there maybe. Molarity equals the number of moles divided by the volume of solution in liters. So you've given the molarity, so you don't have to calculate this time. It's 0.25 equals the number of moles. You've already got the number of moles of the unknown is 367 divided by the volume. I don't know why I put that mole there. Sorry. So you have 0.25 equals 367 divided by the volume. So now you take the cross multiply there. You have 0.25V equals 367. Then you take 367 divided by 0.25. Remember, dividing 0.25 by both sides. Therefore, the volume on number 6 is 1,468 liters of solution. That's what you're looking for. There's your final answer there. Hopefully everybody understands that. Like I said, tomorrow I'm going to give you a test to see how much you know. It'll be a tough little test because stoichiometry is kind of tough, but I want you to see if you can do it. Please do your own work. Do your own work on this today as well. But you'll have all these different things from stoichiometry we've been covering the last couple of weeks. So good luck with yourself. Y'all stay safe, and I will see you the next time. Take care. Bye.